Okay. So let's actually start with hypothesis. First and foremost thing, if you actually see the um, the project, right? First is the topic, whatever the topic that we have actually selected. Okay. So anybody wants to tell one example topic, we can probably take it based on that rest of the thing. Anybody wants to take the topic? Their topic?
Yeah, okay. I'll tell.
Yes.
But there are 3 variables. Will it be
No,
confusing?
that's okay. Tell the topic name. We'll go through based on that.
Okay. The effect of self-esteem on body image and food addiction.
Effect of
Self-esteem
self-esteem.
on body image
Yes.
and food addiction. I
Okay.
will write in chat also.
Yes. So here, if you see what we are actually saying here is the topic of effect of self-esteem on body image and on body image and self-esteem.
Food addiction.
Food addiction and food addiction, right? So basically, if you if you take this topic, first and foremost thing is what we are trying to prove. Okay, so what we are trying to prove? What we are trying to prove is what is hypothesis. Okay, so this can be viewed in multiple directions to see the hypothesis, right? I mean, if you are actually forming the hypothesis on this particular statement, in your project report, we will have at least one or more hypotheses in and around this topic. For example, are we saying that self-esteem will have an impact on body? I mean, will have an impact because of the body image? So whether we are getting, so basically, is there any relationship between body image and self-esteem, right? That is exactly what you would want to actually prove as one of the hypotheses. Or whether the food addiction is having any kind of effect on self-esteem or not, right? So hypothesis one could be whether body image has got anything to do on self-esteem, whether food addiction has got anything to do with self-esteem. So the hypothesis is you are trying to say that whether you have an impact or not, right? Whether you have a relationship or not, right? So there could be 2 hypotheses, or in some kind of projects you might have 3 hypotheses. If you go to your project report, where to find what is your hypothesis, right? You can go to project report, and in the section which is explaining the methodology, hypothesis would be stated. So it in case of most of the projects, you would have anywhere between 1 to 3. Okay, so more than 3 hypotheses is rare, but you might have, in some cases we have 1, in some cases we have like up to 3 hypotheses stated. So if we take this topic itself, we talked about 2 hypotheses: whether body image has got any correlation to self-esteem, whether food addiction has got any correlation with the self-esteem, right? So now there are 2 types when we talk about hypothesis types, right? The question is about, so you understood what is hypothesis, right? What you are trying to prove is hypothesis. So once you take the project, once you take this particular title, from there itself, you are actually trying to put a statement whether body image has got any correlation with the self-esteem, whether body image affects self-esteem or not, right? So that is exactly what would be your hypothesis. So it is about your topic and what you are trying to prove in your topic. So now, what is null hypothesis? So null hypothesis is an accepted truth. So basically what we are saying here is, let's say if I take the same topic, whether self-esteem is impacted because of body esteem, if I fail to prove, right, what exactly is the accepted truth? There is no relationship. So I don't really have to prove anything to say that there is no relationship. So even if I don't do this project, the fact would remain same that there is no relationship between body image and self-esteem, right? If I manage to do some statistical algorithm and prove something that there is a relationship, then only I'm actually proving that there is a relationship, right? So accepted truth is null hypothesis. That means if your project fails, you took the data and your data says that there is no relationship, then that accepted truth without your project is null hypothesis. What is alternate hypothesis? Alternate hypothesis is the one which you are trying to prove. Okay. So basically, whatever that you are trying to prove is what is the alternate hypothesis. Okay. Okay. Any questions here? Did we understand what is null hypothesis?
Yes.
Okay. Okay. So now we are talking about, see, so now from hypothesis, right? So how you are going to prove your hypothesis? So we are going into what are the things that you are actually doing. The first and foremost that you do is you are trying to collect some data, right? So how you are going to collect the data? In most of our cases, we would have actually used questionnaire as the tool. Very rarely we would have a project which does have a different other techniques, but we used survey technique where we took the tool which is questionnaire, which actually gives the data for us. So we reached out to, so the first and foremost that we used survey technique to actually gather data. So we actually floated around the survey, and in the tool, in the survey, we used specific questionnaires. So for example, what these particular tools are. See, ultimately, if I see the same topic, which is effect of self-esteem, right? Effect on self-esteem, okay, because of body image and on food addiction, right? What you are actually measuring. There are three variables here, okay? Variable one, we are talking about self-esteem. Variable two, we are talking about body image. Variable three that we are talking about food addiction, right? So there are three variables. So if you talk about variable types, okay, so one is independent variable, the other is dependent variable. Okay, there are other variable types as well. I'm making it easy to mainly concentrate on project related questions and answers. Okay, so there are independent variables and dependent variables. Every project will have independent variables and dependent variables. So there are other types of variables like control variables, etc., etc., whatever it is. I'm not talking about all other types of variables, but most important aspect is independent variables and dependent variables as far as your project is concerned. So what is independent variable? Independent variables are the ones which are like they are not dependent on anything. For example, body image here could be an independent variable, okay, and you are just checking self-esteem, which is dependent variable, and checking whether your self-esteem is being affected by body image or not. So you are varying the body image and then checking whether self-esteem is being modified or not, right? So dependent variable is self-esteem. Food addiction is again an independent variable. So body image and food addiction are independent variables here. Dependent variable is self-esteem. You are actually checking whether self-esteem is being affected because of my body image, because of my food addiction, right? So this is dependent on body image and food addiction. So dependent variable is the right side of the equation. Basically, you are just so left side of the equation, which is variables which you can independently modify or independently existing are the independent variables. Okay. So is this aspect understood? What is independent and what is dependent variable?
Yes.
Okay.
Yes.
Okay. So now comes to the aspect of right. So now again we are going back to the survey and tools and other stuff, right? So if you see this project, obviously we used survey technique to survey it, right? So uh, if we have to actually use survey technique and also if you see various variable, right? Here we are talking about emotional, we are talking about self-esteem. So now the question is how you are going to measure self-esteem by just asking some questionnaire. So what happened is these so-called scientists gathered some standard questions using which they also even gathered some scoring techniques so that you can measure self-esteem based on the answers given by people. Okay. So what we ended up doing is we gathered tools, rather these questionnaires, which are pre-developed by some standard scientists. Like for example, there could be one scientist who would have devised a questionnaire to measure self-esteem. Some other scientist would have devised a questionnaire to measure body image. Some other scientist would have made a questionnaire to capture food addiction. So every variable that we have here, there would be an associated tool using which you are going to measure. So this tool is nothing but the questionnaire that we have. Okay. When there is a question related to tools, they are asking about what are these questionnaires that you used to measure these variables. Ultimately, once I get the data, I need to convert this into some some mathematical value so that I need to run some algorithms. So using these tools, I'm converting the questions which are given in the questionnaire into the mathematical data, and then I'm applying techniques of statistics to actually do some analysis, whether there is a relationship or not here, right? So tools are nothing but these questionnaires, and every variable will have one or more tools that you use in your project. Most probably there would be 1:1 relationship between your variable and the tool that you are using. Okay. So three variables, you might have three different questionnaires to calculate the value. Okay. So that is what is the tools. So now coming to the point of, so in the survey, you would have actually using this questionnaire in the survey, you would have actually circulated to the people, and you would also have something called as a control variables in your project. Okay. So control variables are something that which are not directly involved here, but they are the ones which are guiding your project. So what does it mean? For example, in this particular case, what is the age group that you are targeting? Maybe self-esteem might not have been, there might not be any effect of self-esteem in the below 18 age group. But there could be an effect when we are talking about age group of something above, right? Even though age is not directly being talked about here, but that is something that we would want to state as something that we are putting as a control factor, right? And also in some cases, maybe we are talking about limiting to certain educated people or limiting to urban class. So you would have actually put some statements in and around your project to limit your boundaries, and that you are using it as a control where you are actually saying that, okay, I'm going to actually measure only for so and so age group. I'm going to measure only male. I'm going to measure only female, or I'm going to measure only urban people and not the rural people. Something like that. So all these things, every project will have one section which talks about what are the factors that you are actually keeping it under control. So you are not really measuring it as a separate variable, but you are keeping it as the one of the thing which you are actually controlling. You are actually limiting your boundaries of this particular thing, and you are not letting that variable affect your overall result, right? So that is another aspect if you, to remember when it comes to variables here. Okay, so you need to know for your project what are the conditions that and what are the boundaries that you have put. Okay, so now coming to the next part, which is statistical part. So once we collect this particular data, we would have got scores based on whatever the questionnaire that we would have actually done, right? I mean, every questionnaire will have a different scoring technique, and using that scoring technique, we would have got this particular end score, right? So now this end score is something that you are going to do the analysis on. So there are three popular analyzing techniques. Okay, I'll go one by one. So first and foremost, in this particular case, if I take this particular case itself, right, you are checking whether so and so variable is actually having any correlation, or does it really affect the other variable. So this is a classic case of correlation. Okay, so what does correlation mean, right? Especially this is used in the case of you are checking so and so variable has got any relationship with so and so variable or not. So here again the topic is we are talking about the self-esteem and body image. If I vary body image, is my self-esteem being varied or not? Okay, so typically we use here Pearson correlation if it is a data which is purely quantitative or quantitative in nature, right? So basically you are talking about fully mathematical data, not really true or false kind of a thing, or there are various types of data. Okay, qualitative data, quantitative data. Okay, so quantitative is something which are purely numbers, and 99% of your projects we might really end up using quantitative data, because ultimately most of our algorithms work better when it comes to quantitative. If it is qualitative data, there are different sets of correlation algorithms which are there. Okay, so limiting very focused here, most of us would have used Pearson correlation, which shoots quantitative data, because most of our projects have quantitative data, which is mathematical data ultimately. Okay, so correlation is about checking relationship between two variables, here self-esteem and body image. So Pearson correlation is one type of correlation algorithm which is used to check whether there is a, so it tells whether there is a relationship or not. Okay, it also tells the type of relationship, whether it is directly proportional or indirectly proportional. For example, you are saying that whether my body image, if my body image is high, is self-esteem is also high, or is it ulta? If my body image is high, my self-esteem is low. Is it inversely proportional? So when I calculate my Pearson correlation, using that, I will be able to tell whether there is a relationship or not. I'll be able to tell that how strong is that relationship, And I will also be able to tell which direction it is, whether it is directly proportional or indirectly proportional. So these are the three things that I will be able to measure when I use correlation algorithm. Okay. So a lot of projects would have used this correlation technique whenever there is a relationship or a correlation between two variables are being measured. Okay. So, so is uh, any doubts on what is correlation? So no, I'm assuming that there are no.
It's clear.
There,
It's clear, Praveen.
okay.
Can
So
you tell
three
about
things.
the t-test also, please?
I will go into that. I'll go into that.
Oh, okay.
So let me complete correlation, then I will take t-test. So there are three techniques, as I said, most of our projects used. One is correlation, second is t-test, third is regression. Okay, so these are the three techniques. I mean, I think 99% of the projects use these three techniques only. Okay, so I'll cover these three. So first is correlation. Correlation, as I said, we are actually covering three aspects. One is whether there is a relationship between these two variables, how strong is the relationship, and how what is the direction of the relationship. These are the three techniques. What it doesn't tell, so you need to understand this particular aspect very well. In Viva, they might actually ask, what correlation doesn't tell you is what is the reason between the relationship. For example, your project proved that there is a relationship between body image and self-esteem. You proved that there is a relationship. Okay. But if somebody asks why, you don't know. Okay. So you don't know the reason why there is a relationship. Even after you proving that there is a relationship, you don't know the reason why. Okay. So that part is something that you don't know. So typically correlation, so when you actually apply Pearson correlation or any other correlation, you will get a value between -1 to 1. So if it is minus, then what it means is it is negatively correlation. That means inversely proportional. If it is positive, it is directly proportional. Okay. So, and the strength of your relationship depends on how close your value is for one. For example, if your value is zero 0.8, that means it is strongly correlated. If your value is 0.6, then it is actually medium correlation. If your value is something like 0.3 or something like that, very mild correlation. Okay, very mild correlation. If your point is 0, if it is nearing 0, then that means there is no correlation. 0 means no correlation. Anything near 0 means no correlation. Okay. If your correlation is -8, it is strongly correlated but negatively correlated. -0.8 is strongly correlated but negatively correlated. So inversely proportional, but there is a relationship. So, and in our project, we'll have a table that most of us would have used to tell that, okay, yeah, based on this correlation coefficient, whether you would have written in the conclusion, whether it is strongly correlated or medium correlation or mild correlation, whatever it is. Check what is your conclusion. In that, we would have made that particular statement. This correlation is like strongly correlated and positively correlated, negatively correlated. So this particular thing is derived based on correlation coefficient. Okay. So now going into the second aspect, which is t-test. Okay. So t-test typically comes in a statement where you are just checking the validity of your statement. See, for example, I'll give you an example. Wait. So basically, it is
Praveen,
like,
Praveen, sorry to interrupt you. Go by
yes,
her
yes.
example only. What is that independent variable and dependent, and what the variables are adding to it? So just go by that. It will be understood.
Okay, fine, fine. Yeah. So here, what we are actually doing here is, see, when you are actually measuring, see, typically, if you are in this particular case, let's say if the measurement is done in such a way, if you take this particular topic itself, if the measurement is done in such a way that, let's say, you divided the crowd into two parts. Okay, so uh, here the crowd with high body image, the crowd with low body image. Let's say you have two groups. Group 1 has got high body image. Group 2 has got low body image, let's say. Okay. And you floated your questionnaire, which says that, okay, yes, this particular high body image group, what is the self-esteem? You measured self-esteem for group 1, which is of high body image group. What is the self-esteem result? Group 2, which is low body image group, you are again floated the same questionnaire and measured the self-esteem. Okay. So now you are comparing group 1 and group 2, whether group 1's self-esteem is different from group 2's self-esteem. Okay. So here, where you are measuring is, you are not really measuring, comparing the variables. You are not comparing body image with self-esteem as a correlation. Here, rather, what you are doing is, you are comparing the groups to check whether body image is having an effect on self-esteem or not. Group 1 with low body image group, group 2 which is high body image group, you are measuring self-esteem for group 1, you are measuring self-esteem for group 2, and you are checking whether group 1 and group 2 does have I mean, basically they are having similar correlation, similar self-esteem, or whether they have like different self-esteem. If you prove that group 1's self-esteem is different from groups 2's self-esteem, if there is a difference between group 1 and group 2 on self-esteem, that means you proved that body image is having an effect on self-esteem. Are you getting my point? So you are choosing the groups, group 1 and group 2, and you are checking whether there is a difference between group 1 and group 2 on self-esteem or not. If you are doing this, the algorithm that you are going to use is t-test. So t-test will actually allow you to actually check, compare group 1 and group 2 here. Okay, whether there is a significant difference or not between these two groups. Okay, so are you actually getting a significant difference or not? So whether the difference is significant, so whatever the value that you got between the above group and this group, is the value significant here or not, is what is that you are actually measuring here. So the significance is so basically why you require t-test, right? So you can just measure the value of the above group and second group, and then I'm going to actually just chumma check that particular self-esteem is 1.25. This group's self-esteem average is 1.5. So hence hence you can actually say that there is a difference of 0.25 of self-esteem. So hence there is a difference. You can conclude in that way, right? But you can't do that statistically. The reason is, in general, as a population, there could be differences in the self-esteems, right? So you cannot just simply take the average, and if the average is different, you cannot conclude saying that both the groups are different in nature. So this 0.25, whatever the difference that came on the average, whether that is significant or not, you need to actually check whether 0.25 is significant or it just happened because there is some random error, right? People might have of different self-esteems. Hence, by chance, there is a difference of 0.25, right? How do you actually determine that? So that's exactly what t-test solves. So it understands the general standard error that could really, have in your sampling. Okay, so there would be some differences between individuals by default. It might not be because of the body image, right? So in order to actually compensate that standard error, compensate that particular standard deviations that could be there, t-test really comes into play. Okay, so how you are going to actually do the t-test? So using statistical technique, you would end up actually finding the t-value. Okay, so here, so how using that particular value, how you are going to determine the ultimate thing, right? So we have something called as a significance. So significance is nothing but you are actually telling that what is your confidence level. So confidence level is when you actually come with the result, you need to actually state that with 95% of confidence, 95% of confidence, my result says that there is a significant difference. Okay, or with 90% of the confidence, my result says this is what is the so you are talking about how confident you are in terms of your result. The more confident you are, the better. Obviously, depending on research to research. In case of medical research, typically your confidence level has to be high. You need to have at least 99% of confidence because you can't really go wrong. But in our most of the projects, we would have followed 95% of confidence. So if you have 95% of confidence, then our result is valid. Okay. So in case of t-test, what we would have actually got, okay, we would have got something called as the t value. Okay, and just a moment, I'm getting 1 minute. Hello.
Stop the recording.
So we are at the t-test, right? So basically, t-test is used when you are comparing something and you are comparing the groups and saying whether there is a significant difference between group 1 and group 2 or not. Right? So that's exactly what t-test would actually help you to do that. So how you are doing it? There is something called as a t-value that you actually get when you run the algorithm. Okay, here we are not really going.
Praveen, sorry
You're
to
not
interrupt, but you're not clearly audible.
Hello, can you hear me?
Your sound is very distant. Your voice is very distant.
Let me take my headset off. Hello, can you hear me now?
No.
Hello. Okay. So what we are actually talking about is t-test, and t-test is used to actually compare between two groups and whether your two groups are significantly different or two groups are you don't have a significant difference, right? You don't have a significant difference. Let's say in this particular case, group 1, which is like having a high body image, and group 2, which is having low body image. If there are two groups, you are saying that these two groups doesn't have any significant difference. That means what you are proving? You are proving that body image doesn't play any role in your self-esteem, right? If you find out that there is a significant difference between group 1 and group 2, what you are proving? You are proving that body image does play a role because group 1 seems to be different from group 2. So how you are going to measure? There is something called as a t-value that you actually end up getting. And this t-value is converted into p-value. Okay. So this so there is a t-table. Using the t-table, you are going to actually tell this particular p-value for a specific t-value. So if you see the data, whatever that you have actually published, there would be a table in your project report. In that table, you will have this t-value, you will have this p-value. Okay. So we talked about confidence. So if this p-value ends up being less than 0.05, 0.05 means 95% of confidence. Okay. So most of our projects might have 0.05 as your confidence level. So if this p-value is less than this 0.05, which is 95% confidence, you are telling that I have a significant difference. If this p-value is less than 0.05, I have a significant difference. If this is not less than 0.05, that means more than 0.05, the difference is not significant. So as I said, if the difference is not significant, what you are saying group 1 and group 2 both are same. So that means you are not able to actually prove that this body image does have an effect or not. So you are saying that there is no significant difference. So what your hypothesis, your null hypothesis cannot be rejected. So null hypothesis, as I said, is the accepted truth. So rejecting null hypothesis means you are able to prove something new. You are able to prove your alternate hypothesis as correct. Okay. So here, if the value of P is less than 0.05, you would have mentioned in your table that it is a significant difference. So significant difference means in your conclusion, you are saying that yes, group 1 is different from group 2. That means body image does have a role to play. So it is affecting the self-esteem. That is what you would have actually written. So t-value, using t-value, using p-value, you would have labeled whether there is a significant difference or difference is insignificant. This is how t-test is used. Okay, so t-test has got two types of t-tests. Okay, the example that I gave is the where you are measuring group 1 and group 2. Okay, there is another type of t-test which actually measures the same group. Okay, you are, let's say you are trying to measure same group before taking medicine, after taking medicine, whether there is a difference between these two. It is very unlikely that anybody would have used this kind of a t-test, but there is another type of t-test which is called as a paired t-test. Paired t-test. Okay, this is generally used if you are trying to measure for the same group before taking tablet, after taking tablet, or before doing this work, after doing this work, whether there is an effect or not. So there also you use t-test. Okay, which is called as a paired t-test. There also you will get p-value and you will get p-value. Using p-value, you will say whether there is a significant difference or not. Okay, but most of our cases, we wouldn't have done paired t-test. We would have done a normal t-test, which is measuring whether there is a difference between group 1 and group 2. Okay, so this is the t-test. So any questions on t-test as of now?
So
So now
Praveen,
move-
even if it's a paired t-test, I mean, the result will be the same, right? It's calculated the same way, right?
Exactly. The calculation methodology changes. The paired t-test does have a different algorithm to work, but ultimately it is t value that is going to come, and t value, using t value, you are going to get p value, and you are going to check whether this p value is less than 0.05. If it is less than 0.05, there is a significant difference. If it is more than 0.05, it is not insignificant difference.
Okay.
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 That conclusion part remains the same, but when it comes to statistical algorithm, paid t-test has got a different way to calculate. Okay, normal t-test does have a different way to calculate.
But they won't ask all those things, no?
No. Okay, the simple, obviously in the Viva, they will not ask you to solve t-test because it takes a little bit of time, it takes a little bit of calculation. So don't worry about your equations and all. The way that we would have actually done in our project is we would have used SPSS software. So how SPSS software works is you give all the data to it and ask that particular tool to calculate t-test. It will calculate and give t value, p value.
Oh, okay.
So in the project, we wouldn't have manually done the t-test. We wouldn't have manually done the Pearson correlation. So don't worry about remembering the formulas and all those stuff. It is very unlikely to ask that. Okay. You need to know where you need to use correlation, where you need to use t-test. Depending on your hypothesis, if you are checking whether there is a relationship between two variables, you would have used correlation. If you are doing using the technique like comparing two groups and then telling whether there is a relationship or not, then you would have used t-test. Okay.
Okay, got it. Yeah.
If your hypothesis says that I am checking the relationship between these two variables, then most likely correlation would have used. But in your hypothesis, if you are saying whether there is a significant difference on, if your hypothesis says whether there is a significant difference on the self-esteem, on high body between high body image group and low body image group, then you would end up using t-test. Okay.
Got it.
So now we are going into the third one, which is regression. Yeah.
Praveen, before we go on that, Usha, how many tables you have in the project?
I have got 1, 2, 3, 4.
4. So that means you have 4 hypotheses?
Yeah, because I have also done it according to gender.
Correct. So if there are 5, there will be 4 kind of tables.
Yes.
You have got a mean and a standard deviation, wherein based on that, what Praveen said, no, what T and P value come, based on that, the SPSS would have given you some data, mean SDs, standard deviations.
Yes.
And if it's close to that, as in to say, then you have to draw a conclusion. Yes, 18 to so many years, whatever hypothesis, every table will have a value coming across as per the SPSS, and then you give a conclusion to it. Okay.
Yeah.
Yeah.
Right.
Yeah. So anything on t-test that people want to know? Is it clear? Okay, let's go to the next one.
Actually, if nobody has studied, no questions will be asked, so there will be no. Sorry, don't mind this, but it's okay. Okay, padayega to pata chalega types, like that.
Yeah.
Praveen, I have a small doubt. I don't know if it is. See, when I was just going through some of those questions which I had sent, right? There is something called, what is the research design that you have used?
No, we'll come to that.
Oh, that is something different, because correlation, some word came, I thought it is the same. It's different, right? Okay,
no. Research design is different.
Okay.
Okay.
Fine.
So yeah, we'll go to that. Okay. So anyway, the one of the design aspect is the algorithm that you are actually using. So correlation does have a role to that, but there is a way. I mean, uh, so ultimately, I mean, the term used in a different way. That's all. Okay. So correlation is also part of it. So correlation is one of the research designs. So which algorithm to use, etc., comes under your research design. Okay. So there are various types of research designs which are there. Correlation, descriptive designs, etc., are some of the types of research designs. Yes. The correlation algorithm that I talked about is purely, I'm talking about the mathematical way of solving correlation coefficient and that other stuff. Okay, so yeah, there is a, I mean, correlation research design type. Okay, so there is something called as an explorative design type or experimental design type and all those stuff. But we'll go to that particular research design a little later. Okay, let's complete the statistical part first. Okay.
Yes,
So
okay.
so next, going into the aspect of regression. Okay, so regression is very similar to your correlation, but regression is much more what do you say, advanced when it comes to this particular correlation. So where regression really comes, let's say you are saying that I have x and y, two variables, both are related. What correlation is telling whether they are related or not. Okay, and how strongly they are related also it is saying. But what correlation doesn't say is, if I give you x value, can you find out can you predict what would be the y value? Let's say in the research statement, whatever that we have talked about, if you are trying to do a research and say that, yes, self-esteem is dependent on body image, but okay, let's say I want to go to the next level and say that I will give you his body image or her body image. Can you predict what would be our self-esteem score? Can you do that? So basically, I will tell that body image score I got as no 1.25. Now tell me predict what would be your self-esteem. So if I have to do that, if I am able to predict whether self-esteem, I mean, get the self-esteem using body image, then I use regression algorithm to find out regression coefficient. Okay. So what it really means here, I'm not only telling that there is a relationship between body image and self-esteem, I am also telling that I'm saying that, okay, yes, this I can predict self-esteem using the body image. So this is much more advanced, or rather a very strong way of saying that these two variables are correlated to some extent. Okay, so wherever you are, I mean, in some cases, instead of Pearson correlation, we would have went through regression coefficient to check the relationship between these two attributes. So using regression method, what you would have done is you would have actually measured something called as a regression coefficient. Okay, so regression coefficient, what it says, it signifies the amount of change that, let's say, x change this much, how much this change would impact y, right? What would be the corresponding change in y when the x is getting impacted? That is exactly what this regression coefficient says. So if this regression coefficient is very less, what it really means is the impact of x on y is very less. That means they are not so correlated, right? The impact is very small. It is not significant. That is exactly what this coefficient tells you. So if this coefficient is negative, what it means is the slope of that particular regression is in negative direction. This is inversely proportional. So basically, if x increases, y decreases. If x decreases, y increases because it is negative regression coefficient. So it also tells the direction just like your correlation coefficient. Okay. So not just direction, it tells the intensity, how much x would be impacting y. So it is little more advanced when compared to your correlation technique. Okay. So you will end up finding regression coefficient. Using regression coefficient, you would actually end up telling that how much x would impact y. Okay. So this is about regression. Any questions on regression? Like correlation coefficient, here you are actually checking regression coefficient. Okay. And so typically there are various types of correlation, various types of regressions. We would have used in our case linear regression. Okay. So there is a logical regression, etc., etc. There are various types of regressions, but it is very unlikely that we would have used any advanced regressions. We would have used linear regression. So linear regression comes into play when you are assuming that the relationship between x and y is linear in nature. Linear is nothing but straight. Okay, it's like a straight line. So if you put up a graph, there is a straight line kind of a thing that would come. So this is like a linear regression that we are talking about. Okay. So this is about regression. So we covered 3 techniques, and I am pretty sure that 99% of the projects would have used these out of one of these 3 techniques. One is correlation, second is T, and third is regression. Okay. So read through your hypothesis statement. Based on that, you would have used the statistical technique, whether it is T, whether it is correlation, whether it is the other one. Okay. Regression. Okay. So this is about statistical techniques or algorithm. You don't really have to find out solving techniques. Ideally, we would have actually studied during our MPC 006, but it is very unlikely in the Viva that they would ask you to actually write the formulas. Okay, you need to actually tell how you interpreted this course. In case of t-test, you interpreted based on p-value that it comes. If it is less than 0.0805, significant. If it is more than that, insignificant or not significant. In case of correlation, it would vary from -1 to 1. So you are actually predicting whether it is weak correlation or strong correlation, etc., etc. Okay. In case of regression, you would have found regression coefficient. Using regression coefficient, you are actually telling whether it is, there is a relationship and how strong is your relationship. Okay. So you would have used all these particular things on top of the tools that you would have used to calculate value of self-esteem or value of body image or etc., etc. You would have used questionnaires to do that. And these questionnaires are nothing but the tools that you are actually trying to, arrive at. And you have variables, which is independent variables and dependent variables that we talked about. We also talked about control variables like age and gender or whatever it is that you would have actually controlled on it. Okay. And in your methodology, in the project report, if you go to methodology section, you will see your aim of the study, which is research problem, objectives of your study, variables. You would have mentioned variables. What are your variables, and what are dependent variables? What are independent variables? And then you would have mentioned hypothesis. So typically 1, 2, 3, or in case of Usha, there are 4 hypotheses. Read through your hypothesis statements. What is your hypothesis? Okay, then there are actually definition sections. We'll talk about definition sections tomorrow. Let's concentrate on statistical parts first. Next, you would have told what is your sampling size. Most of us would have actually sample size of at least 60. According to IGNOU, I think they actually consider something as 60 as something which is like a baseline. In case previously, if somebody would have mentioned less than 60, rather they would have given a comment in the synopsis approval to have at least 60. Okay, so sample size would be at least 60. And if you have more variables and more comparison, this could actually go even beyond 60. The idea is at least per group, you should have 30, because why 30 is the moment the sample is at least more than 30, you can, it actually comes to a parametric test. Okay. If it is less than 30, it is because of a small sample size, it would be qualified as non-parametric test. Parametric test gives more confidence. They are more accurate in nature. Hence, the sampling would have done at least in and around 60 in most of our case. So in your report, you can check there is a section called as a sample. We would have mentioned those particular sample size and other stuff. Okay, in case if question comes, why exactly 60 or why 30, more than 30, to get better confidence, right? I mean, ultimately, if you're using parametric techniques, then larger the sample size, the better the confidence that you have. And to qualify it as parametric test, you require at least 30. Okay, so less than 30, it would not be qualified as a parametric test. It will be qualified as a non-parametric test. So also in your project report, in the methodology itself, you would have mentioned tools. Okay. Okay. So just a moment.
Recording in progress.
Yeah, hello. Okay, so now you would have actually used in your project, you will have a section called as tools. So get to know what questionnaires that you would have used. And there is a section called as statistical technique. In that, you would have mentioned whether it is a t-test, whether it is a correlation that we have used. So as I said, depending on the hypothesis that we'll have based on that, we would have chosen t-test or correlation or whatever it is. Okay. So apart from the t-test, the other things, we would have used one more thing, which is called as a descriptive statistics. Okay. So here, what it means descriptive is, apart from just concluding that I have a significant difference, I have an insignificant difference, I have a correlation, I have a strong correlation, I have a weak correlation. Apart from this, we would have actually collected various types of statistics, like, okay, depending on the age group, depending on the gender, what is the average of what is the average of self-esteem in case of male, what is the average, what is the thing in case of female. We would have actually done some statistical algorithms, like simple thing like finding the average for so and so age group, finding the standard deviation for so and so age group, right? And all these interpretations based on simple averages and other stuff, these all will fall under descriptive. Okay, so here you are describing. So why describing descriptive? You are just describing based on your sample. You are just telling the observations, saying that, okay, yes, my mean value in case of male is higher when compared to in case of female. Okay, whether you are not really comparing and telling whether this difference is significant or insignificant or anything like that. You are just describing your sample. You are just telling your observations, saying that, okay, when I did for male, this is what is the self-esteem score is. When I did females, this is what is the self-esteem score is, average self-esteem score. And seems to be that mean value of female is higher. So
So maybe higher when compared to male. Whether this so your study is not really doing a t-test to tell whether it is significant difference between male and female or not. Descriptive analysis is only about you are describing the data in various directions. You are just describing, I have this much of sample size, in that 30 are male, in that 30 are female. I have like 10 people of age group between 20 to 25. I have like 20 people between 25 to 50. Average of 20 to 25 self-esteem score is 1.5. Average of self-esteem score from 25 to 35 is like 2.5, etc., etc. You're just describing your sample. That is descriptive analysis. Okay, so every project report would have this descriptive analysis as well to describe your observations on your sample and the collected data. Okay, but your conclusion is not based on descriptive analysis. Descriptive analysis is not there to conclude anything. Okay, this is only describing your samples. Conclusion is still happening based on your t-test, based on your correlation, based on your regression. Okay, but this descriptive analysis would actually give us good insights for people to really understand your samples, understand your data, and this can actually give some kind of indications for future research or gaps within your research and all those stuff. Okay, so let's say if data says that there is a average score is high for female when compared to male, maybe that is one of the research statements that could you can actually do it as a subsequent project, or you can use t-test and then check add as a new hypothesis to your project, etc., etc. Those all things can be done. So descriptive analysis will actually give a good overview of what exactly are your observations. Okay, so so this is so I think it is very late. So do we want to